Hi guys, this is Miss Woolley doing the video tonight, so there might be some mistakes going with the pen and working it. So tonight we're going to work on section 5.4, solving compound inequalities. By the end of it, you will be able to solve compound inequalities containing the words and, or, and graph their solutions. So when we think of intersection, we want to really think of an overlap between two. So an example would be 8th graders take math and science. You take them both. For a union, we think of the terms joining each other. So an example of that would be 8th graders take French or Spanish. You don't usually take them both, but you can. So we're going to go through some examples now. Just kidding. And it's a compound inequality containing and is only true if both inequalities are true. So both of them need to be true. The graph of a compound inequality containing and is the intersection of the graphs of the two inequalities. Every solution of the compound inequality must be a solution of both inequalities. So now we'll move to examples. So example 1, we have graph the solution set of x is less than 2 and x is greater than or equal to negative 1. So we'll start by just graphing x is less than 2. And since it's less than, we'll have the open circle, and it will be everything less than 2. Now we'll graph x is greater than or equal to negative 1. Since it's greater than or equal, we'll have the closed circle, and it will be everything greater. Now when we graph them together, it will be the two endpoints. So we'll start with the negative 1, it will stay colored in circle, and then we'll have the 2, and then the solution is what's in between them. So that would be how we would graph that. A second example is we would have to solve negative 1 less than x plus 2 less than 3. Then we're going to graph it. So you can do it two ways. You can do them in separate inequalities or together. We'll do separate. And then we have x plus 2 is less than 3. So we'll subtract the 2 on both sides. And we have negative 3 is less than x, or if we want to write it this way, x is greater than negative 3. So we will graph that. And again, we'll have the open circle because it's just greater than. And now on the other one, we'll subtract the 2 from each side, and we'll have x is less than 1. So we'll graph that. And again, we'll use the two endpoints, so negative 3 and 1, and it will be what's in between that. Now go ahead and try numbers 1 through 5 on your own, and then start the video again. Okay, so now we are going to move to the or statements. So a compound inequality containing or is true if one or both of the inequalities are true. The graph of a compound inequality containing or is the union of graphs of the two inequalities. The union can be found by graphing both inequalities on the same number line. A solution of the compound inequality is a solution of either inequality, not necessarily both. So now we'll move to an example. So this one's already solved for us. So to graph it, the first part would be 2a plus 1 is less than 11. And we find out that a is less than 5. So we'll go ahead and graph that. And for the other part of the or statement, we solve a is greater than 3a plus 2. And when we solve that, we find out a is less than negative 1. So we'll graph that. Less than negative 1, not 1. Now, since -1 is technically still less than 5, we'll start at the 5, and then everything in that section will be the answer. And we will do one more example. So we have b is greater than 2. So we'll graph that, and then we have b is less than or equal to -3. Now those don't overlap, but that is still the answer solution. They don't always have to overlap. And that is all we have for tonight. So have a good night.